Greetings everyone. My name is Rukumar Vyas from Semester 3, pursuing BTech in Information and Communication Technology ICT at Marwadi University. This conceptualization video is my submission for the active learning assignment for the subject Introduction to Communication Engineering. In this video, we'll be exploring protocols and standards in communication. In a later video, we'll be exploring the Serial Peripheral Interface Protocol, also known as SPI. Before moving on to learn about protocols and standards, let us first understand what is communication. Communication, a word that we often use in our day-to-day lives. In layman terms, communication means talking to each other, either face-to-face, via a mobile phone, via video call, or using apps like WhatsApp or Telegram. The technical definition of communication is a bit more precise. Technically speaking, communication is the process of meaningful, effective, and efficient exchange of useful information or data between two entities connected by a communication channel. These communicating entities can be either humans, as we saw in the previous slide, or they can be electronic devices like computers, servers, sensors, telecommunication devices, etc. If you closely observe your surroundings, then you can find many devices which are communicating with each other. For example, computer and pen drive, mobile phones, remote and TV, etc. When you connect your pen drive to your laptop or computer, at that time there's an exchange of useful information like videos, songs, and other documents between your pen drive and computer. When you call someone, at that time there's an exchange of data, that is your voice, between your mobile phone and the mobile phone of the person at the receiving end. When you control your TV with your remote, at that time there's an exchange of data between your remote and the receiver in the TV. This is the general model of any communication system. Any communication system can be classified as four main components. The first main component is the transmitter, which is denoted as TX. Second is receiver, which is denoted as RX. Third is the communication channel or medium, which interconnects the transmitter and receiver. And fourth is noise and attenuation, which are transmission invariants and are like unwanted guests. Let us now understand each component one by one. The first component is the transmitter. The transmitter is an electronic circuit that converts our information signal or data into suitable form for transmission over a communication medium. The TV remote is the best example of a transmitter. The second component is the communication channel. The communication channel is the medium by which the transmitted signal is sent from the transmitter and is received by the receiver. Wires, optical fibers, free space, etc. are the examples of the transmission media. In our example of TV and remote, the free space acts like the transmission medium. The third component is the receiver. The receiver is an electronic circuit that accepts the transmitted message from the communication channel and converts it back into a form that is understandable by the humans. The best example of a receiver is the FM radio. An FM radio picks up the audio signals from the free space which are transmitted in the form of electromagnetic waves. The FM radio then converts the audio signals which are in the form of electromagnetic waves into signals which are understandable by humans, that is the audio signals. The last component of any electronic communication system are noise and attenuation. Signal attenuation and noise are the unwanted phenomena that are bane of all the communication systems. Noise is an unwanted disturbance that corrupts our message signal. Attenuation is the gradual degradation of our message signal due to the loss of energy in overcoming the resistances of the communicating medium. Noise and attenuation are also known as transmission invariants, which affect our signal transmission negatively. Due to noise and attenuation, the quality of our signal is reduced. Either the amplitude reduces or our signal is mixed with some kind of unwanted disturbance. There is also a third transmission invariant which is known as distortion, which is an internal phenomena occurring in a system. which affects the signal negatively. We will learn about transmission invariants in detail in later video. Let us now move on to learn about protocols. Again, before jumping to the technical definition of protocols, let us first understand why do we need protocols. And we'll do this with the help of a real world example. Assume there are two friends, let's say Jay and Viru. Jay and Viru are exchanging pleasantries. They are talking with each other. Now consider this. Jay starts speaking in French and Viru doesn't understand French. Let's say Jay recently went on a trip to France and there he learned some new French words. Now, obviously, Viru, who doesn't know any French, will not be able to understand what Jay is speaking. So, here a proper communication is not happening. Remember this. Secondly, consider this. Jay starts speaking very fast at supersonic speeds like the rap god Eminem. Viru will not be able to understand what Jay is speaking as he's speaking so fast. Also consider this. When Jay starts speaking, Viru is not paying attention. Viru is looking somewhere else. It is only after when Jay calls Viru by his name that Viru, where is your attention? Viru starts paying attention to what Jay is speaking. Now obviously Viru hasn't listened to things said by Jay before he started paying attention. In this case also, there won't be a proper communication happening between Jay and Viru. Lastly, consider this. Jay starts speaking randomly. Without any proper structure or format, Jay starts blabbering stuff. Here also, Viru will not be able to understand what Jay is speaking. Everything that Jay is speaking will sound gibberish to him. So, in all these three cases, there won't be a meaningful and proper communication happening between Jay and Viru. The issues that we just discussed doesn't only exist in human communication, they are also true for electronic communication. To overcome the issues discussed, we need protocols. Protocols are mutually agreed upon set of rules and regulations that govern data communications. A protocol mainly defines three things: what is communicated, how it is communicated, and when it is communicated. A protocol ensures that there is a systematic, effective, and efficient exchange of information or data between the transmitter and the receiver. As we saw in the Jay and Viru example, Jay and Viru were talking with each other, but we cannot say that there was a successful communication happening between the two. Same is the case with electronic devices. Without a protocol, two devices might be connected with each other, but there won't be any successful data transfer between the two. We use protocols daily at every walk of our life, from surfing the internet to talking with our loved ones using electronic devices. Everywhere protocols are used. Protocols are also used to transfer data from a sensor to a microcontroller or from a microcontroller to an actuator. Examples of some widely used protocols are the TCP/IP protocol, that is the Transmission Control Protocol and Internet Protocol, and IPv4 and IPv6, that is the Internet Protocol version 4 and Internet Protocol version 6, are different versions of the Internet Protocol. Then we have the HTTP protocol, that is Hypertext Transfer Protocol, and lastly there is also UDP, that is User Datagram Protocol. We also have the Serial Peripheral Interface Protocol, abbreviated as SPI, UART, that is Universal Asynchronous Receiver and Transmitter, I2C or I2C, that is Inter-Integrated Circuit, etc. The last three protocols mentioned here are widely used for data communications in embedded systems and Arduino and AVR based systems. Please note, protocol itself is not our message, but it constitutes of our message signal along with some additional information like start bits, stop bits, sender's address, receiver's address, error detection and correction codes. We will see all this later in this video. This additional information is added for successful and proper transmission and reception of our data. Elements of protocol. There are three main elements of any protocol. First is the syntax, second is semantics, and third is timing. Syntax. Syntax refers to the structure or format of the data that is transmitted or received. It describes in what order the components that constitute the sent data are arranged. Here I've taken a very simple and a very random example. The syntax here is defined in such a way that the first 8 bits represent the start bits. The start bits tell the receiver that okay, now the transmitter will start transmitting the data. The next 16 bits are the sender's address. The next 16 bits are the receiver's address. The next 32 bits are the actual data that we want to transmit. The next 16 bits are the error detection and correction code like CRC or checksum. And the last 8 bits are the stop bit, which indicate the receiver that okay, now the transmission is completed. Semantics. Semantics refers to the meaning of each section of bits depending on where they appear in the stream of data, how a particular pattern needs to be interpreted, and what action needs to be taken based on that interpretation is defined by semantics. Here, in this example semantic that I have defined, after receiving the first 8 bits, the receiver will interpret the next 16 bits as the sender's address. Also, the receiver will interpret this bit pattern in hexadecimal. So this bit pattern in hexadecimal corresponds to DF00. This 0x indicates that this value is in hexadecimal. Generally, in hobby electronic circuit, the address of sender and receiver is given in hexadecimal. The sender's address indicates the receiver that from which sender the data is coming if there are multiple senders. The next 16 bits are interpreted as the receiver's address, that is, to which receiver this data is intended to be sent. Also, these 16 bits are interpreted in hexadecimal. This bit pattern corresponds to FE00 in hexadecimal. The next 32 bits correspond to the data that we intend to send. These 32 bits will be interpreted as ASCII. These 32 bits will be divided into 4 chunks of 8 bits. The first chunk corresponds to the ASCII value of capital S. The second chunk corresponds to the ASCII value of lowercase I, third to lowercase n, and fourth to lowercase g. So our message is the word seen. The next 16 bits correspond to the error detection and correction code. Now, based on how our semantic is defined, these 16 bits can be either interpreted as CRC, that is cyclic redundancy check, checksum, or as any other error detection and correction code. And the last 8 bits are interpreted as the stop bits, which indicate that the data transmission is over. Timing. Timing refers to two things: rate at which data can be sent and received, and when it should be sent and received. The transmitter cannot start bombarding the data at the receiver and expect it to understand that data. To work effectively, a protocol needs to ensure that both the sender and the receiver are prepared to communicate with one another at the right time. Now assume that the sender starts sending data at 100 megabits per second, whereas the receiver can only interpret 1 megabits per second. Obviously, there will be overloading of the receiver. Thus, a protocol also needs to ensure that data isn't sent at speeds too high or too low for the other to interpret. Standards. Standards are guidelines or conditions that have been adopted by vendors and manufacturers for effective communication and interoperability. Interoperability means the ability of different systems, devices, applications, or products to connect and communicate with each other without any hassle. Standards must be followed when a new design is to be formulated. For example, the 802.3 standard gives the specifications related to the Ethernet. If anyone in the world wants to design a software or hardware related to the Ethernet, then they would have to follow those specifications. If these specifications are followed, then that new design would work with all the pre-existing as well as the future software or hardware of the Ethernet. Standards are categorized into two categories: de facto standards, meaning by fact or by convention, and de jure standards, meaning by law or by regulation. De facto standards. Standards that have not been approved by an organized body but have been adopted as standards through widespread use are called de facto standards. Imagine I'm a manufacturer and I have developed a new product or technology. Now the existing standards do not work properly with my device or I'm facing some other issues. Then I can make my own standard to facilitate the working of my device. But as I am not an organized body or an official body, the standard that I have created will be known as de facto standard. Thus, de facto standards are often established originally by manufacturers who seek to define the functionality of a new product or technology. Examples of de facto standards are the Serial Peripheral Interface Protocol, abbreviated as SPI protocol. SPI protocol was developed originally by Motorola back in 1980s. Motorola is now also known as FreeSpace. The other example of de facto standard is the QWERTY keyboard. De jure standards. Standards that have been legislated by an officially recognized body are called de jure standards. These standards are developed through the cooperation of standard creation committees, forums, and government regulatory agencies. Examples of de jure standards are the American Standard Code for Information Interchange, also known as ASCII, and other example is TCP/IP. Some of the standard creation committees are International Organization for Standardization (ISO), American National Standards Institute (ANSI), and Institute of Electrical and Electronics Engineers, famously known as IEEE. Let us discuss the importance of standards. It is due to standards only that the pen drive you buy in your city can be used with any computer or laptop in any part of the world. All this is possible thanks to the USB, which is standardized. If there weren't any standards, then every company would make the products according to their wish. Then the pen drive of one company would not work with the laptop of another company. There would be a complete chaos. So to prevent this chaos, standards are implemented. We have reached the end of this video. I hope you liked this video and also learned something new. I would like to thank Professor C.D. Parmar sir, HOD ICT Department, for his thorough guidance in making this video. While making this video for the active learning assignment, I learned many new things apart from textbooks and also explored new resources which are very helpful. I'll be giving a link of all the useful resources and references in the description below. Lastly, I would like to end with a quote. It is quoted by Richard Feynman. If you want to master something, teach it. Thank you. Have a good day ahead.